topic, which is arithmetic and geometric sequences. So these ones you will see in the future in calculus and in statistics, so I found this important to cover. If we look here, arithmetic sequences, if a sequence of value follows a pattern of adding a fixed number, so that's the keyword there, is adding. From one term to the next, it is referred to an arithmetic sequence. The number added to each term is always the same, and it is called the common difference. And then they denote that with the letter D. To find the common difference, subtract the first term from the second term. So here it says, find the common difference, D, in the following arithmetic sequences. So if we look here, from 1 to 4, okay, for us to find, we do 4 minus 1, and that gives us 3. Okay, so that means that the difference from here, 1 to 4, to get that number, we add 3. From 4 to 7, we add 3. From 7 to 10, we add 3. From 10 to 13, we add 3. From 13 to 16, we add 3. So that means that our common difference is 3. Okay, let's go ahead and look at the next example. Here we go from 15 to 10. So you go ahead and take the second number, which is 10, and you subtract the first number, which is 15, and that gives us negative 5. So if you notice from here to here, you add a negative 5, or you subtract 5. So 15 minus 5 gives you 10. 10 minus 5 is 5. 5 minus 5 gives you 0. 0 minus 5 gives you negative 5. Negative 5 minus 5 gives you negative 10. So your common difference is negative 5. And the last one. So to get from 1 to 1/2, you do 1/2 minus 1. And that gives you negative 1/2. So from 1 to 1/2, that means you have to subtract 1/2. 1/2 minus 1/2 gives you 0. 0 minus 1/2 gives you negative 1/2. So our common difference here is negative 1/2. Alrighty, so here it says the formula to find any term in an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Okay, so that is a very intimidating formula at first. So D is a common difference. Okay, that's what we already know. We know D is a common difference. I don't want you guys to get super scared. N stands for any number. It says N is a number of the term to find. So if you want to find the first number in the sequence, that's what N stands for. You use a 1. If you want to find the 10th term in the sequence, so the 10th number in the sequence, that means N is 10. And then a sub 1 just means that's the first number. Okay, a sub 1 is the first term of the sequence. Okay, so it seems kind of complicated, but it's not too bad. So here it says find the indicated term in the following arithmetic sequences. So I'm going to go ahead and copy down the formula here. So a sub n equals a sub 1 plus n minus 1 times d. I'm going to go ahead and write it twice because we're going to need it for the next one. Plus n minus 1 times d. All right. So if we look here, it says find the 18th term. So since they tell us they want us to find the a sub 18, that means that they want our n to be 18. We're looking for the 18th number, okay? So it might be kind of easy to just keep on adding or subtracting a number to find that one, but it's a little bit of work. So to take a little shortcut, we use this formula. Now remember, a sub 1 stands for the first term in the sequence. So if we look here, the first term here is 5. So instead of a sub 1, we put 5. And then plus, we have n minus 1 times d, the common difference. So that's what we have to find is the common difference. So between 5 and 13, if we do 13 minus 5, that gives us 8. So that means that the common difference here is going to be that it's adding 8 plus 8 all the way through. So our common difference is 8. We go ahead and put all of this into our calculator. And that gives us 141. So, so for our 18th term in the sequence, it should be 141. So I actually should have put an 18 here. All right. Let's go ahead and try it on the next problem. All right, so a sub n, they want us to find the 24th term in the sequence. So I'm going to put a sub 24. And you don't want to be adding or subtracting a number 24 times. That is just way too much. So instead of n, we're going to plug in 24. Remember, a sub 1 stands for the first term in the sequence. So the first term in the sequence here is 10. Okay, so we are looking for the 24th number is equal to 10 plus our n, which is 24, minus 1. So all we have left is to find the common difference. So to get from 10 to 4, we would have to subtract 6. From 4 to negative 2, we would have to subtract 6. From negative 2 to negative 8, it's minus 6. So that means the common difference is negative 6. Okay. So I'm going to go ahead and plug all of this in my calculator the way I see it. So 10 times 24 minus 1 times a negative 6, and that gives us negative 128. So our 24th term in the sequence is equal to negative 120. All right. On to the next one. So here it says find the missing terms in the arithmetic sequence. So we're looking for these missing terms. So in order for us to find those missing terms, we do need to figure out what the common difference is. So I'm going to go ahead and take my formula. I'm going to copy it down. So a sub n equals a sub 1 plus n minus 1 times our common difference, okay? And now we don't know what the common difference is. That's how we're going to find the other numbers, but we do know a few things. We do know that our first number here is 7. So I do know a sub 1 is 7. I also know that my fifth term, so 1, 2, 3, 4, 5, my fifth term is 23. So 23 equals 7 plus, and then 23 is my fifth term. So 5 minus 1 times my common difference. And that's what I want to find is my common difference. I don't know what it is. That's what we're looking for. So we know 5 minus 1 gives us 4. So 7 plus 4 times d. And now we're solving for the common difference. So we're going to solve for the letter d. So I'm going to subtract the 7 first. And 23 minus 7 gives us 16 equals 4 times d. And we divide by 4 to solve for d. And we find out that our common difference is 4. So the letter d equals 4. So now we know our common difference. So 7 plus 4 gives us 11. Plus 4 gives us 15. Plus 4 gives us 19. Plus another 4 gives us 23. All right, so let's go ahead and try that again. So here we have a sub n. I'm going to write down the formula again. A sub n equals a sub 1 plus n minus 1 times d. Oh. And remember, d is a common difference. That's what we're looking for. That's what we're trying to find so that we can fill in the rest of the blanks. Okay. So we're going to put in or plug in what we know. So we do know the first number is 9. So a sub 1, I'm going to put 9. Now, we do know that the fifth term, 1, 2, 3, 4, oh no, wait, 1, 2, 3, 4, 5, the sixth term. So instead of n, that is the sixth term. And we know the sixth term is equal to 10. All right, so 10 equals 9 plus 6 minus 1. And then the common difference, we don't know what that is. That's what we're trying to figure out. So we're going to start solving for the common difference. So 10 equals 9 plus 6 minus 1 gives you 5 times d. And then we start solving for d. So we need to move over the 9 to the other side of the equal sign. So 10 minus 9 gives us 1. This cancels out. And this gives us 5 times d. So our last step is to divide by 5. And that gives us our common difference to be 1/5. All right. So then 1/5 written as a decimal is going to be 0.2. So our common difference is adding 0.2. So on here, 9 plus 0.2 gives us 9.2. Plus another 0.2 would give us 9.4. Plus another 0.2 would give us 9.6. Plus another 0.2 would give us 9.8. And then plus another 0.2 gives you 10. So that's what we're adding is 0.2. Alrighty. Let's look at the next section. So now we have geometric sequences. So if a sequence of values follows a pattern of multiplying a fixed number, so now we'll be multiplying times each term to arrive at the following term. It is referred to a geometric sequence. The number multiplied each time is always the same, and it is called the common ratio. So what we're using now is our common ratio. To find the common ratio, divide the second term by the first term. So it's kind of like we did with the arithmetic sequences, but instead of subtracting the second by the first, we're going to divide the second term by the first. So find r in the following sequences. So to find r, I am going to have to take the second term, which is 10, and we are going to divide it by the first term, which is 5. So 10 divided by 5 gives us 2. So that means that from 5 to 10, that's times 2. From 10 to 20 is times 2. From 20 to 40 is times 2. All right. So then let's look at the next one. To find the common ratio on this one, we're going to take the second term, which is 22, and divide it by the first term, which is negative 11, and this gives us negative 2. So my common ratio is negative 2. That means that negative 11 times negative 2 is going to give you the positive 22. So that's how come the signs change. We take 22 and multiply it times negative 2. That is going to give you a negative 44. And we do the same thing. That's how you get the negative 88. All right, the next one. So here we are going to find the common ratio. So we take the second term, which is 8/3, and we divide it by our first term, which is 4. Okay, so if you're not sure how to divide these, I'm going to show you. You do 4 is the same thing as 4/1. Without the calculator, you multiply these two. 8 times 1 gives you 8. And then you multiply the inside ones. 3 times 4 gives you 12. And that's if you don't want to use a calculator, if you don't have a calculator available. And then we can't just leave it as 8/12 because that is not a simplified fraction. So if we simplified this, this would give us 2/3. So that is our common ratio. So that means from 4 to get to 8/3, they multiply times 2/3. And then to get from 8/3 to 16/9, they multiply times 2/3, and so on. So now let's go ahead and look at the formula for our geometric sequence. It is going to be a sub n. So to find any number that you want, you're going to have to take the first term and multiply it by the common ratio for the number that you want in the sequence, so n minus 1. So a sub 1 is the first term, it tells you here. Of the sequence, r is the common ratio. And then n is the number that you want to find. So if we look here, they want us to find a sub 8 of the sequence. So let me go ahead and copy down the formula. A sub n equals a sub 1 times r to the power of n minus 1. Okay, so they want us to find, since they put a little 8 here, that means that they want us to find the 8th term of the sequence. So a sub 8 equals, we find a sub 1, which is the first term in the sequence. In this case, it is 0.5. We multiply it times the ratio, the common ratio. So in order for us to find what number we're multiplying, to find r, we have to take the second term, which is 3.5, and we divide it by the first term. So 3.5 divided by 0.5 is going to give you 1.75. Wait, sorry, I didn't put that in the calculator right. 3.5 divided by 0.5 is 7. I thought that was weird. Okay, so 7 is our common ratio. And then n is the number of term that we're looking for. So we're looking for the 8th term in the sequence. The 8 comes from here. So 8 minus 1. And we go ahead and punch all that in our calculators exactly the way we see it. So 0.5 times 7 to the power of 8 minus 1. And that is going to give us our 8th term in the sequence is going to be 411,771.5. All right, let's try the next one. So they want us to find the 11th term in the sequence. So we start off by writing the formula. So a sub n equals our first term times our common ratio to the power of n minus 1. So they want us to find the 11th term in the sequence. So a sub 11 equals, and then instead of n, I'm going to put an 11. Minus 1. And then our first term here is 1. So instead of a sub 1, we're going to put 1 times our common ratio. So our common ratio is the number that we are multiplying by. So what number do we multiply times 1 to get negative 1/2? So remember, if you're not sure, you can go ahead and take the second term, which is negative 1/2, and you divide it by the first term. And that gives us negative 1/2. So then we put that in our calculator exactly the way we see it. 1 times negative 1/2 to the power of 11 minus 1. Or you could put it as a power of 10 because 11 minus 1 gives you 10. And that gives us, it is a very small number. And so it did give it to me in scientific notation. So 1, 0, 2, 4. And we have to move over 1, 2, 3, 4, 5, 6. There you go. Which in that case, it is a very small number. That's it. Was that the last of it? Yeah. So if you guys have any questions, go ahead and leave it in the comments below. Send me an email. Or go ahead and stop by our office hours so we can help you out with this. Thank you guys for watching. Bye.